things may be a little similar like than in China, but I don't know it at the moment. So we'll see what is done at the big Missouri River or whatever the bridge is.
Thank you. Hello, my name is Genda Chen, Professor of Civil Engineering at Missouri SNT. I would like to, maybe I can mute for
Of 1,500 bridge collapses.
I would like to take this opportunity to thank the organizer for accommodating my request for his presentation last minute. Basically, we are developing a smart rock technology and for real-time bridge scale monitoring. And basically, we integrate smart rocks with embedded electronics and sensors and into the process of a scale so that as scale develops, we can, the rock will roll and move to the bottom of the hole automatically so we can determine the maximum scale depth which is badly needed for bridge stability assessment in real time. In a harsh environment, you can see here, the existing technology in this application face a challenge with real-time monitoring, basically. Going to let it go.
Inches of rain, according to the National Weather Service, resulting in closures of both I-44 and US 63 highways. If scour developed significantly at the bridge foundations during the flood event, the flooded bridge could have become unstable or even collapsed, threatening the lives of travelers on the highways and residents that live downstream of the rivers. Therefore, real-time monitoring of bridge scour is not only critical to maintain ground transportation services, but also a safety issue in a time window of hours or days during high flood seasons. To meet the critical need for real-time scour monitoring, since 2011, Missouri University of Science and Technology, commonly referred to as Missouri S&T, has been investigating smart rock technologies that can be integrated with commonly used rip-rap countermeasures, with rocks for cost-effectiveness and robustness in harsh environments. For example, several smart rocks are distributed against the side faces and around the perimeter of a footing or foundation cap of an existing or new pier. Once undermined during a flood event, a properly designed smart rock, slightly larger or heavier than natural rocks near the foundations, falls and always stays at the bottom of the developing scour hole so that the maximum scour depth can be monitored and determined. To facilitate the monitoring of smart rock positions, a heavy and square master smart rock can be placed as needed on top of the footing or foundation cap to serve as a reference point, collect data from nearby small smart rocks, and transmit data to a remote station. Both passive and active smart rocks have been developed as field agents that can be spatially distributed around a bridge pier. Passive smart rocks are rocks with embedded permanent magnets whose intensity was measured at a distance using a magnetometer. By triangulation, a passive smart rock can be located from the magnetic field intensities measured with one or more magnetometers from at least 3 stations. The location of the smart rock gives the maximum scour depth that is used in engineering design and assessment for foundation scour effects. Active smart rocks are rocks with embedded electronics with wireless magneto-inductive communication so that the individual rocks can be wakened, take pertinent data, and transmit useful information to a receiving station. Each active smart rock is equipped with a 3-axis accelerometer, a 3-axis magnetometer, a gyroscope, a pressure sensor as needed, an ID, a timer, a battery level indicator, and an antenna with wireless magneto-inductive communication. The active smart rock can communicate with the base station to form a global communication network, or other smart rocks to form a local wireless network. It can be located with the so-called received signal strength indicator from the base station and other active smart rocks, which is mathematically analogous to the intensity-distance relation in passive smart rocks. The total weight of each 18-inch diameter smart rock deployed around bridge foundations ranges from 150 to 200 pounds and only costing a few $100s. As such, each rock is assembled at a job site, then loaded on a boat and dropped off at a designated place in the river. The total magnetic field strength of passive smart rocks in the Earth is directly measured with one or more magnetometers at various stations. The effect of the passive smart rocks on the Earth's magnetic field is then extracted with the mathematical algorithm developed in this study. Finally, the extracted data is cleansed by filtering and smoothing and is used to determine the location of passive smart rocks by the triangulation technique illustrated previously based on the in situ measured magnetic field intensities and their corresponding calibration curves or intensity distance relations developed from laboratory tests. An active smart rock deployed around a bridge foundation can be waken up with a wake-up message with binary code sent from a receiving station or other nearby smart rocks. The active smart rock then begins the acquisition from various embedded sensors, recording acceleration, magnetic field intensity, rotation, and water depth, and sends the acquired data to the receiving station. The received data is finally cleansed and decoded for the received signal strength indicator, from which the location of an individual active smart rock is determined with a simple triangulation or more advanced neutral network analysis. Scour around the foundation.
I want to say a few words to end this video. The challenge with the existing technology in this particular application is the real-time monitoring in a harsh environment during a flood event. And these smart rocks are smart in two senses. One, you can automatically roll to the bottom of the hole so that we can get the maximum scour depth that is needed for design and maintenance. And potentially this technology can address the #1 cause of bridge collapses. In the past 40 years, more than 1,500 bridge collapses in this country, but 60% of them are due to scour effect. I will leave that. Thank you.
Thank you very much. Very interesting subject.